This is a video for OCR Pure Core Mathematics, Calculus 4, Integration Techniques, 4.4, Substituting x equals tan u. We should already know a relationship between the integral of 1 over 1 plus x squared and arctan, that sec squared and tan squared are related, and that sec squared is the derivative of tan. The substitution x equals tan u may be useful in integrating functions that involve 1 plus x squared. Remember, if x is tan u, then u is equal to arc tan x. And this 1 plus x squared here, and this integral at arc tan x, makes me think that there may be some kind of link here, and that may be useful when we do our integrating. Let's have a look at this example. I've got a function involving 1 plus x squared, but I've also got limits, and I need to make sure that I transform those when I do the substitution. So let's try our substitution. We're going to let x equal tan u. So that means that dx by du is equal to sec squared u. And therefore, when I do the substitution, I will replace dx with sec squared u du. Now I need to think about the limits. So if x is equal to 1, then tan u is equal to 1, and so u is pi by 4. And if x equals 0, tan u is equal to 0, so u is equal to 0. So now I've got everything I need to do the substitution. It's going to be the integral between 0 and pi by 4 of 1 over 1 plus tan squared u to the power 3 over 2, and that's times sec squared u du. Well, that's going to give me integral between 0 and pi by 4. On the top I've got sec squared u du, and on the bottom 1 plus tan squared is sec squared to the power 3 over 2 is, well, that's the square root, so it's sec, and then cube it, so I get sec cubed u. Sec squared on the top will cancel off with 2 out of the 3 in the sec cubed on the bottom. So that's going to give me finally the integral between 0 and pi by 4 of 1 over sec u du. So that's going to give me just the integral between 0 and pi by 4 of cos u du. And that, of course, is just sine. And that's evaluated between 0 and pi by 4. So this gives me 1 over root 2 minus 0, which is just 1 over root 2. There's that algebra tidied up and worked through for you. There's the substitution. There's the transformation of the limits, working on down to our result of 1 over root 2. Let's look at this second example. Again, I've got a 1 plus x squared type thing. I'm going to try x equals tan u. Again, dx by du is going to be sec squared. And so when I do the substitution, I'll again replace dx with sec squared u du. I haven't got any limits to transform, so let's plug those bits in and see what we get. I get the integral of 3 tan u plus 2 over tan squared u plus 1, and that's times sec squared u du. 1 plus tan squared on the bottom is sec squared. So in fact, these two bits will go, leaving me with just the integral of 3 tan u plus 2. So I'm going to get here, integrate 3 tan, I get 3 log mod sec u plus 2u plus c. I know from my substitution up here that tan u is equal to x. So I can write that sec squared u, which I know is 1 plus tan squared, is equal to 1 plus x squared, and so sec u is equal to the square root of 1 plus x squared. So I can put this back into my expression here, and I'm going to get 3 log root 1 plus x squared plus twice arc tan x plus c. Square root of 1 plus x squared, well, that's a power of half, which I can bring out as a coefficient for the log. So this is now going to be 3 over 2 log 1 plus x squared plus twice arc tan x plus c. Again, there's that tidied up for you. We've got here the substitution, and here the technique for working back from sec u to an expression involving x, and here's our final result down here. So in summary then, we've seen that integrals involving 1 plus x squared might benefit from using a substitution of x equals tan u. The resulting integral might need a further technique to be applied, and in particular when you're trying to convert back into an expression involving x. And finally, that definite integrals need to have the limits transformed to allow you to use that for the new variable. The next video in this sequence is 4.5, substituting x equals a sine u or x equals a tan u.